Hello everyone. Let's have a look at today's contest at LeetCode. The fourth question of the contest was minimum cost walk in weighted graph. So let me read the question. The question says we are given with an undirected weighted graph with n vertices and it is following a zero-based index. That is, the nodes vertices are labeled from 0 to n minus 1. We are provided with an array in edges where edges at the index of I denotes ui, vi, wi. It means there is a edge connecting ui to vi with a weight of wi. A walk on a graph is a sequence of vertices and edges. The walk starts and ends with a vertex, and each edge connects the vertex that comes before it and the vertex that comes after it. It's important to note that a walk may visit the same edge or vertex more than once. This is the important line to note. You will understand it later. That we can visit any node or edge as many times as we want, even more than once. And the cost of a walk starting at node U and ending at node V is defined as the bitwise AND of the weights of the edges traversed during the walk. It means you have to do the bitwise AND of all the edges that we have traversed. So let us, we are given with a 2D array query where query at the index of I denotes SITI. It means we need to find the minimum cost of the walk if we start from S and we end at T. If any such walk do not exist, then we need to return -1 in that particular case. And we have to return the array answer, where answer at the index of I will denote the minimum cost for that particular ith query. So let me explain the question with the help of an example also. See, n was given to us as 5 and there was edges given to us and the queries given. These three things are provided to us. With the help of edges, data given to us, we have crafted a graph 0, 1, 7. An edge connecting 0, 1 has a weight of 7. An edge connecting 1 and 3 has a weight of 7. And an edge connecting 1 and 2 has a weight of 1. And n is equals to 5. It means nodes will be labeled from 0 to 4. So they form the 1 component and 4 does not belongs to this particular component. Now, the minimum distance from 0 to 3 will be, if I traverse from 0 to 1, it will be 7. If I go from 1 to 2, it will be 1. If I go from 2 to 1, it will again be 1. And if I go from 1 to 3, it will be 7. Since I already told you, we can visit a particular edge or a node more than once also. So that is why we are traveling in this way. So if what will the bitwise end? It will be 7 and 1 and 1 and 7. I hope you all are getting. So the resultant bitwise that we will get after performing the operation will be 1. So this is the minimum cost that is in order to reach from vertex 0 to vertex 3. I hope you all are understanding it. So the main logic is, if I want to go from any node to any node in this particular component, then the minimum cost will always be 1. If I want to go from 0 to 2, or if I want to go from 0 to 1, or if I want to go from 0 to 3, the minimum cost in each and every case will be 1. So this is the important point to note. In the second example, we have crafted a graph. We need to return query 1, minimum cost to reach from 1 to 2. So in this particular case, it is going to be 0. How? If I go from 1 to 2, first of all, the edge will be costing us 1. If I go from 2 to 1, it will be 6. If I go again from 1 to 2, it will be 1. So 1 and 6 and 1 will give us 0. So that is why we have returned 0. So I hope you all would have understood the question. So let me explain you the question with the help of code. I have tried to solving this problem with the help of DFS algorithm. So what we did first of all is, we have made the adjacency list. Since it's a weighted graph, so it will be pair in comma in. ADJ E at the index of 0 is connecting to ADJ E at the index of 1. It means edge at the index of 0 is connected to edge at the index of 1 with a cost of edge at the index of 2. So I hope you all know how to craft an adjacency list. We just did that in line number 19 to line number 23. After that, we have made one visitors array and we have made one counter variable. as -1. For int I equals to 0 and less than an I plus plus, we do not require this mn. We can eliminate it as well. If vis at the index of I double equals to -1, it means that particular node is not yet visited. So what I will do, I will increment the value of counter and then I will perform the DFS. I will call my function DFS. Now, why I am doing this count? Say, what will this help us to do is, let me explain you. If this is belongs to one component, 0, 1, 3, and 2 belongs to one component, 4 belongs to the other component. So this value of counter will help us to manage that, help us to identify that this belongs to a single component. If counter equals to 0, it means for index 0 also it will be 0, for 1 also it will be 0, for 3 also it will be 0, and 2 also it will be 0. It means they belongs to one component. 4 will be, for 4 the counter will be 1. And so counter variable will be same for the nodes belonging to the same component. Since I already told you, if I want a distance from 0 to 1 or 0 to 3 or from 0 to 2, it will be same because they belongs to the same component. That is why we need a counter variable. So we have incremented the value of counter, then we have called the DFS function. After that, in what we did in DFS is we just put visitors at the index of I equals to counter. So all the nodes belonging to a same component will be initialized with this value count CNT only. After that, I have traversed through my adjacency list. If it is yet unvisited, I am calling my DFS. I hope you all know the DFS function. We studied it in graphs. After that, we have made one minimum weight vector. Vector and minimum weight counter plus 1 int max. Initially, we have defined it with int max. We are traversing through each and every edge. Min weight visitors at the index of E at the index of 0. What will this return? This will return the value of a particular E at the index of 0 belongs to which component. So, and this E at the index of 0 will return the value of the count. So if 0 and 1 belong to the same component, then this E at the index of 0 and this E at the index of 1 will be similar. So minimum weight I have calculated by performing the bitwise AND operator. E at the index of 2 is denoting the cost connecting these particular edges. After that, I have made one answer. Now, this is important. Now we are traversing through our queries. If Q at the index of 0 is not equals to Q at the index of 1, if visitors Q at the index of 0 is not equal to visitors at Q at the index of 1, what is this condition signifying? This condition tells us that these two vertices belongs to different components. If these two vertices belongs to different components, it is not possible for us to reach Q at the index of 1 from Q at the index of 0. So what we are doing is we are pushing back minus. ANS dot push back -1 because it is not possible to reach at any cost. If Q at the index of 0 double equals to Q at the index of 1, if I want to travel from 2 to 2, or if I want to travel from 3 to 3, so the minimum cost will be 0 in that particular case. So ANS dot push back 0. Otherwise, what we are going to do is we are doing is min await visitors Q at the index of 0. And after that, we will return our answer field. So I hope the question is clear to you all. The main funda of the question is, the main important thing which you need to understand is nodes belonging to the same component. If I want to travel from any vertex to any other vertex of the same component, the cost will always be same. So I hope the question is clear to you all. If the question is clear, don't forget to subscribe to our channel and share it with your friends. Thank you.